This is our ABE 100 project on water resources by Timon Kukla, Justin Genova, Cody Sedlock, and Nick Pulaski. Today, the world has experienced a shortage of drinking water. While 70.9% of the Earth's surface is composed of water, less than 3% of it is drinkable. From the chart, we can see that extreme stress is mostly located in the Middle East and North African areas. In highly developed countries, water purification plants relieve stress with treatment plants pumping millions of gallons of water per day. Each plant uses a common process of purification that consists of coagulation, sedimentation, filtration, and disinfection. Turbidity is the cloudiness of water. There are three processes to remove turbidity: flash mixing, coagulation, and flocculation. During flash mixing, particles are whirled around in water at high speed with a coagulant for no more than a minute while forming floc. The way coagulation works is by neutralizing the electrical charges on particles in the water, which then allows them to bunch together and sink to the bottom. Flocculation is when particles are mixed around at slower speeds, forming larger clumps of floc at the bottom of the holding tank. Sedimentation is the process in which material is carried to the bottom of a body of water and forms a solid layer. This happens when the velocity of the water is lowered below the suspension velocity and particles settle out of the water due to gravity. These particles form sedimentation basins at the bottom of a body of water. After this process, 90% of the suspended particles from the water should be removed, including bacteria. Common filters in drinking water treatment are the slow sand filter and the rapid sand filter. The slow sand filter is commonly used in groundwater applications. It cleans 0.015 to 0.15 gallons per minute per feet squared, requiring a large area of land to be effective. While it requires more space, it removes turbidity and pathogens better than other filters. The rapid sand filter is most commonly used filter for surface water treatment. It is small and compact and cleans 2 to 3 gallons per minute per feet squared. Through straining and adsorption, the attraction of dissolved solids to other materials, even the smallest particles, may be removed. Disinfection is used mostly by chemical means. The most frequently used type of disinfection is chlorination, which is adding chlorine to water in order to kill or inactivate pathogenic organisms and stop the spread of waterborne diseases. Because of the amount of treatment, the U.S. has one of the safest drinking reservoirs in the world. But how clean is safe? The EPA sets strict standards that these plants must meet in order for drinking water to be approved for distribution. The quality of drinking water is measured on disinfection byproducts, disinfectants, chemicals, and turbidity, which indicates the presence of harmful microorganisms. If we have the technology, why doesn't everyone have clean, drinkable water? The average American uses 100 gallons a day, while the average African uses around 3 gallons per day. If these purification plants can relieve stress and are a viable solution in the U.S. water problem, why aren't they used everywhere else in the world? We spoke to Dr. Kalita about this problem, and he told us that this comes from the fact that undeveloped countries do not have the technology or resources to operate these purifiers. They often bathe and drink from the same water source that may be miles away. The real problem lies in how to create a sustainable water system for people in undeveloped countries. If you are interested in helping out, UIUC Engineers Without Borders creates sand filters and donates them to villages in Africa.